Welcome everyone to our RFID webinar. We will get started since it's 8 a.m. Central Time. We are super excited to have you here and thrilled to have Wolfgang as our presenter to share his knowledge when it comes to RFID. I'm Christy Kester, John Henry Foster's Marketing and Communications Manager. Just a couple housekeeping items. It sounds like everybody is on mute, but if you do have questions throughout the webinar, we ask that you write them in the chat box and Wolfgang will answer these probably toward the end of the webinar, but if something pops up that catches his eye, I'm sure he might feel moved to answer right then and there. And just so you're all aware, after the webinar has ended, we'll send an email with a form for you to fill out if you're interested in a complimentary on-site visit with Baloff to test proof of concept. It's just a great opportunity to explore more. So take it away, Wolfgang. Thank you so much.
Thank you. My name is Wolfgang Kratzenberg. My title at Baloff is Traceability Sales Specialist. I've been with Baloff for almost right on 9 years now. That'll be 9 years next month. And my focus since being at Baloff has been 100% RFID. And some of you may know Baloff, some of you may not be as familiar with us. We're a global company. We're in 73 countries worldwide. We're based in Neuhausen, Germany. Our U.S. office is based in Florence, Kentucky, which is essentially in the greater Cincinnati area. We're on the Kentucky side. And today, just want to talk to you about applications within RFID, things that we've been successful at, the applications that we see year in, year out, decade after decade in some cases with the ones that have been around for a long time. So without further ado, I'm going to jump right into the presentation. And again, if you have questions, please feel free to throw them in the chat. Someone will be looking at them, and then we can stop halfway through if we need to do that, or we can just wait till the end and kind of take them all there. And of course, if you have a question that's going to require taking a look at an application or something like that, contact your rep at JH Foster. We'll get everybody involved that needs to be involved and dig down into the details of that. So. Sorry here, just trying to get there we go. So just to talk about the industries that we serve. So a ton of different industries across basically anything in manufacturing. And I always kind of sum it up that way. From an RFID perspective, if you make something, you can use RFID, and it's being used. It used to be one of those luxury technologies. Now it's a no-brainer technology. It's everywhere. So a lot of times when you hear the term traceability, you think barcode and RFID, and that's exactly how we think at Baloff as well, because we do both. But from an industry perspective, the automotive industry is where Baloff was born globally. We started off in automotive tier 1. We've moved in over the years. When I say we've been doing this for a long time, actually 2021 is our 100-year anniversary. So again, our core competency is in this industrial space. So the automotive industry, packaging, and packaging within food and beverage, pharmaceutical and cosmetics, steel and metallurgy, semiconductor, of course, intralogistics usually is what everybody thinks of when they think of RFID. But as you'll see after the presentation today, we do a whole lot more than that. Mobile equipment. This can be AGV. This can be, of course, heavy equipment. Transport systems. There's so many other what would fall under the mobile equipment segment. So many applications within that industry that we address as well. Metalworking, and when we talk about RFID at Baloff, everybody usually thinks Baloff is. We're kind of like the Kleenex of the tissue world and the what we call the tool ID world. So this is putting a tag on the side of a tool holder that would go into a CNC machine. There's a little chip on there, and a lot of people will call that the Baloff chip. and that tag records data in the machining process and automatically transfers that information. And then, of course, life science. So I mentioned all these up here ahead of time. We do this and a whole lot more, and we can hit on that. So talked about the industries, and now what about the applications within those industries? And this is just a slide that I put together, and this is actually available on a one-page PDF if you're interested in just having this at your desk to understand, hey, is this something Baloff can address or not? And I did not mention the other products that Baloff have. Again, if you're not familiar with Baloff, we also do sensors, we do networking, we do cables, measurement devices, indicator lights, the full realm of industrial process equipment. So back into RFID, this is kind of just a quick summary. So I mentioned work in process, asset tracking, access control, logistics, and automated replenishment. Those 5 applications make up just about everything that's being done in a plant where, again, something is being made. So a manufacturing plant of some sort, wouldn't matter if you're manufacturing food and beverage or nuts and bolts. And then the top right of this slide, we just talk about the features of our systems. And I'm not going to get into all the details of the features. We do have the largest portfolio in the RFID market. So there's a lot of different ways to address a lot of different applications. And that's one of the benefits of doing business with Baloff on the RFID side, is we probably have something that fits your application when in the past you've tried it before. It's probably time to take a look at it again, because technology has progressed over the last few years to whether it be small form factors, high temperatures, harsh environments. That's a big part of our portfolio. And again, form factors due to tight spaces and machines that are being built, and the high memory capacity. And we'll talk about how to choose tags later, and that high memory capacity will come back into play. And again, for multiple architectures. So we don't manufacture PLCs, but we connect to just about every major control platform. So when you think about, how am I going to connect my readers that are on a production line to a PLC? And you say, well, I have a Siemens PLC. We can check that box. It's Allen Bradley PLC. We can check that box. So we do Ethernet IP, Profinet, Profibus, CC Link, EtherCAT, also TCP IP, and RS-232, and even USB. So again, a ton of different ways to get our products on your network. So digging into the applications here a little bit, work in process. So if you make something, you do work in process. It starts out as a piece of raw material and it ends up as a finished good. And how do you track that along the way? How do you manage the quality? How do you track the lineage data? Is where did my components come from? And again, that's become really critical in today's day and age of just knowing who your suppliers are, trying to control that supply chain, and understanding is that if we have a recall, how do I make a more focused recall instead of doing a very broad and sometimes expensive recall? Doing work instructions for operators would be another example, and how RFID is used in work in process. And then moving on to asset tracking. And this is really a big one. I mentioned machine tool data transfer earlier. This eliminates the need to have an operator sitting up there punching in numbers or keying in numbers that may be, 6-7 digits long, and the decimal point is in, the third position. One little switch around of that decimal point can cause a crash in a CNC. And I'm sure if you guys are in the machining world, you've seen that happen. It does happen all the time. So we can help prevent that with RFID. A really big application for us is mold and die setup parameters, and that's tracking the molds and the dies. And really, when you think about it, a mold and the die is a tool no different than the actual machine tool that goes into a CNC. The mold and the die is a tool that goes into a press. Same concept. Container content verification. What is actually in a container, and I'll show you these applications in detail shortly to kind of flesh that out for you a little bit. A really big application for us right now, especially in packaging, is change part verification. So how do I make sure if I'm going to switch from running a 12-ounce container to a 16-ounce container, that means I got to change out the tools on my line to make that happen. Well, how do I make sure every single tool, let's just say I had a dozen tools that had to be changed out to make that 16-ounce box run smoothly? Well, if I only change out 11 of those tools and I got one that's still set for the 12-ounce, I can cause major problems on the line. One, I cause downtime, which is an absolute unacceptable thing in our world. Two, it can cause a crash, a machine crash, cause damage to the machine, which again, in turn, cause downtime and have to bring somebody out to repair the machine in addition to that. I also mentioned AGV tracking. AGVs and automatic guided vehicles is very big right now, and that's just being able to track like location and flow control around the plant. How can I maximize that path of the automated guided vehicle around my plant? RFID is used for that. The one in the middle, access control. This is one that, so I want to clarify what this means for Baloff. We are not the commercial RFID company that you tag into to allow you into your building. That's not our type of access control. Others are good at that. We let that be. Our access control is limiting machine access. So if you think you want to be able to limit operators or limit the number of people who can log into a machine, who can lock out a machine, who can stop the line, things like that. Essentially eliminated the old key to shut down a line or to start a line, using an employee badge with a tag on the back of it, just a small label on the back. And if somebody tries to share that label, maybe he tries to pick it off and put it on somebody else's badge, it'll self-destruct. So in addition to that, operator accountability. So if you think about it, if you have 50 workstations on the line and maybe 35 of those are manned workstations, you want to know who's working in each station there. You can have operators log into that station so you can go back. Let's just say you have a quality problem and you realize that the consistent problem is that, the person at station 45, there's a unusual number of parts that are rejected after it comes out of that station, and you can act accordingly after that. Again, it's just about creating some level of accountability as who was at that station when the problem occurred. Logistics, and I mentioned this earlier, is everyone thinks that, when you think logistics, that's when everybody thinks RFID. Probably comes from the Walmart initiative, probably 15 years ago now, where they said they were going to tag everything coming into their store. Realistically, and that was great for them. That was great marketing for RFID globally, and a great pump for RFID. But realistically, there's a ton of different ways to do that. And as I'll talk about a little bit later, there's also some challenges within that world. When you start using UHF as opposed to HF, there's some challenges in the environment that can come up, and we'll talk about that here shortly. But very commonly within the industrial sector, we're tracking raw materials as they come in the door. Where are those raw materials when I need to start production? Do I have enough on hand? So it's inventory optimization, et cetera. Sequencing applications. How do I make sure when I ship the product that I'm making to the next person in the supply chain, is it in the correct order coming off the truck? That's the just-in-time concept. That's very big in the automotive industry right now. And then, of course, I mentioned optimization and inventory, and also optimization and shipping as well. So, of course, we do every list of hardware as far as RFID goes, from about that. As far as RFID goes, we do the tags, the readers, and the processors. And there's always three components to every RFID system. So we do the full gamut of hardware. In addition to that, we are also a software solution provider in that world too. We can handle the data. So automated replenishment. Some of you maybe in the automotive industry is familiar with this term e-Kanban or Kanban itself. It's just a replenishment concept from lean manufacturing. And it's about complying to just-in-time concepts. As how do I make sure when let's just say I'm in a standard production line, I have an operator that has a stock out, let's just say on station 2. How do we replenish the parts that operator was using there? Well, RFID is being used to send an automated message to the central warehouse and says, okay, we're out of number 5 machine bolts at station 2. Let's get those replenished immediately. That way, and the whole concept there is that there's one bin of parts the operator is pulling from, and while that one bin is in play, there's another bin on its way there. So there's never a stock out, and it's optimizing that inventory. So the areas of a plant, and I mentioned, all the different applications that we face, and there's plenty more areas than this, but these are the common areas that we address with RFID. So in plastics, you think about molding. How do we track those molds? A lot of these molds look the exact same. How do we track the molds when they go to the tool room? How do we make sure when we put a mold in a machine that it's the correct mold for the product that we're actually getting ready to make? In the machining world, how do we make sure we have the right tool for the right job? Metal forming, how do we make sure we have the right die in the right press for the right product that's being made? And then how do I find that die when I'm getting ready to make a specific product? I go into the tool room and everything looks the same to an operator. How do I make sure? RFID plays a role in that as well. And I'm call out the tool room here specifically. It's just tracking those individual tools from the time that they come into the plant to the time that they go out of the plant. We can track usage information. If you think about what RFID really is, it's a chip with a piece of memory on it. You can write data to it, and I can read it without touching it. Not to oversimplify it, but really that's what it is. So I can use that fundamental premise to be able to identify exactly where in the plant that I have my assets, and that's what's been critical, and for sure in the last decade with RFID and in the manufacturing plant. Shipping and sequencing, I mentioned that. Well, that's kind of a no-brainer for RFID nowadays, and it's not a matter of whether somebody, whether or not RFID can work anymore. RFID is. And it's whether or not it's being deployed from end-to-end applications in the plant or not. Automated assembly, this is essentially work in process. I may have a tag that's on a pallet from station 1 to station 50. I may have a tag that's actually on the actual part itself. And we can do that as well. Again, we have the largest portfolio in the business, so there's a lot of different ways to attach a tag to a pallet. And if you're not using a pallet, we have a lot of different ways to attach a tag to the actual item that's being built. I mentioned material flow, Kanban, inventory optimization, and then of course in the receiving end of the dock as well, having raw materials come into the plant is where are those raw materials when I need them? That's the key. I know I'm getting ready to build or getting ready to make a certain product. If I want to find that tub of plastic resin, if I want to be able to find whatever that raw material is, perishable food. How do I make sure that it hasn't sit outside of the refrigerated unit or the freezer for a certain period of time? RFID is being used for that. So there's a ton of different ways to address these applications that I'm talking about with RFID and barcode for that matter. Today I'm going to talk more specifically about RFID, but there's a ton of different systems that we have that can address a lot of different applications, and it's all about your application. So someone may call and say, hey, give me an idea of what you guys have for RFID. We have just an RFID catalog that's probably 2 inches thick if you printed it out. But we do LF, meaning low frequency, we do high frequency, and we do UHF. So if RFID can be used to address the application, more than likely we can do it. So starting on the left-hand side here, this is just a multi-channel processor. This can actually do multiple frequencies on one processor. So essentially, there's one processor, you can have all 3 frequencies, LF, HF, and UHF, that goes into one processor. So again, you're like, well, what would that be good for? In a case where you may be doing some machining and then also transporting, so you have a machining center, goes into the machining center, comes out of the machining center and transfers somewhere else. You may be using one frequency while it's inside the CNC, and then as it's being transported down the line, you may be using another frequency for that. Just a standard 2-channel system as well is still, and this is one of our legacy systems. It's been around. The one right here has been around for a really long time. IO Link RFID as well. So IO Link and this processor, what we call a master block. We can put RFID in it. You can put sensors into it, measurement devices, indicator lights, etc. Point-to-point RFID, meaning I have the actual reader and processor is all in one housing, and I connect that directly back to a PLC or a PC. The next one is long-range RFID, meaning usually UHF in that case, if it's long range. And it's being able to read a tag anywhere up to 6 meters away and all the way up to touching that tag. So you may say, well, why wouldn't we just use everything because it has a range that big? Why wouldn't everything just be UHF? Well, there are some benefits to HF over UHF in the sense that if you wanted to write more data to the tag, then HF would be an advantage. If you just want to put just a simple license plate on there or just an identifying number and you want to read that from 5 or 6 feet away, then UHF is the way to go. And we have ways of determining that, a way to drill down to the exact hardware technology that's going to be required for your application. And I'll mention that several times is, everything revolves around what you're trying to accomplish. We don't ever want to have you try to wrap our technology around, or jam our technology into your process and then have to have an operator deal with our technology. The key is how do we mesh our technology into your process and help make that process better. And the last two on here are barcode, both fixed and mobile barcode readers, mobile RFID readers as well. But again, I'm going to focus more on RFID here today. So asset tracking, I mentioned this one specifically because everybody has plant-based assets. Machine tools, for example, and this is just a good example. This tag here that's in the side of this tool holder is about the size of a Tylenol. Very small, it's 10 millimeters in diameter, about 6 millimeters thick, and it goes into the side of the tool holder. Information is written to that tag, all the offset data that happens at the presetter, and then you transfer the tool to the actual machine. And instead of having a clipboard with a bunch of offset information written on there from the measurements that you just took, you read the tag, it automatically transfers it into the CNC machine and updates that register in there. So now you know how much life you have on the tool, how much usage is left on the tool, which tool pocket does it go into when it's finished, what's the diameter of the tool, what's the length of the tool. And essentially, this prevents crashes and tells me where to find the tool when I need the tool. Huge application, and this is where we originated. This is where Baloff RFID originated over 40 years ago, was in this specific application, and we've expanded since. So molds and dies, I mentioned this one is, of course, the setup parameters as well, is when you're getting ready to stamp parts or you're getting ready to mold parts, we can count shots, we can count hits, how much usage. Again, if a mold is only rated for 20,000 hits, how do I manage that? Do I just count that with a mechanical counter? How many hits weren't really hits in that? And am I paying more for refurbishment than I have to because I'm not doing an accurate hit count or an accurate shot count? Just a quick example of how that works. And again, both molds and dies are essentially just tools, and that's the way you have to think of it. And very much the same way as change parts would be. Some of these change parts that are required to change out, format change on a production line for packaging, for example, they look identical. Putting RFID tags on them and then putting a reader below them will confirm that an operator, in fact, has put the correct one in there. So people in the past or customers in the past have used inductive proxies to say, okay, yeah, there's a part here. That's fine in some cases, or that to know that change part is in place. But how do we identify exactly which change part is in place? That's the key. So the difference between RFID and a Proc sensor, for example, is to say a Proc sensor can say, hey, somebody came in the door. RFID can say someone come in the door, here's their name, date, and their license number, for example. So commonly tracked assets, this really comes down, this is probably the most commonly tracked asset around a plant is the actual containers themselves. So I mentioned raw materials, and I keep mentioning that a lot, but especially in food and beverage and really in the life science world is how long did a bin stay outside of a refrigerated area? or how long was something in a explosion an explosion zone in a plant, or how do I keep a specific bin outside of an explosion zone in a plant. Being able to track that bin is really what it comes down to fundamentally. It's about putting a tag on the bin, and then like the one on the right, for example, all these things with the red top, they're batteries, and they had barcodes on them. So as the operator was loading the bin, they were reading the barcodes with a handheld reader, and that handheld reader information would read that barcode, and the data would be automatically written to the RFID tag that's here on the corner. So instead of having to go through that and do the inventory by reading every single barcode, the operator can come up and read the tag, and it'll tell them the exact contents of that container, because as it was being loaded, it was being automatically written to that tag. So AGVs, and I mentioned this one earlier as well. Basically what we're doing is we're putting a tag in the floor. Sometimes in some cases they're burying the tag in the floor. They'll take the concrete out, place a tag in there, concrete over top of it, so operators can, or the plant workers can't even see that there's a tag in the floor. And then there's an actual reader that's on the AGV to tell location. You can identify flow control, the usage, and of course when it needs to be maintained. I mean, everything in the plant has to be maintained. So you talk about predictive or preventative maintenance. This is an application using RFID that is critical, because how do I log all that information? And some people are still doing it on a clipboard and paper, but again, this is rapidly moving to using RFID in this case. So eCanban. And realistically, I like to always sum this up by it's automated replenishment. This is an old Kanban board, or what we just call in the automotive industry a Kanban board. This is how materials being replenishment. It's someone's job to go up here and look at these colored coded cards, or even sometimes bar-coded cards, and that would drive a replenishment at the production line. So it's someone's job to do that. Well, you can imagine these cards can get lost, misplaced. The information can be smudged off of them. Somebody has oil on their hands. You smudge the ink off really easily. We essentially have eliminated the need for that entire board. We put an RFID tag on the side of the bin, and as that bin rolls down in there, it says, okay, we have a bin in play. It's a full bin. When that bin is pulled out of that roll rack and put into the return roll rack, there's a signal that's sent that said, okay, we have an empty bin on station 2. We need to replenish station 2 with number 5 machine bolts, whatever the case may be, or whatever material that needs to be replenished there. So it's about sending that automated signal. There's no need for cards. There's no need for other than to have, and in some cases, there's an AGV that does the running of the material from the central warehouse back to the production line. And I use that term central warehouse to identify exactly where all the raw material is being held. So very common is eCanban, or automated replenishment in that world. Work in process, this is truly, if you make something, everybody has this application within their plant. The question is, with RFID, is what kind of data is being written to the tag? I hear this over and over again to newcomers in the RFID world. And essentially, there's 3 kinds of data is what we've kind of summed it up with. It's either build data, process data, or lineage data. That's the kind of data that's being written to the tag along the process. And the build data is essentially what are we trying to build? And you think about flexible manufacturing, right? So we can start off with just an empty pallet, but before it gets to station 1, you're right on that tag exactly what it's destined to be. That way, every station that it goes into, you may have an operator, a manned station, and that operator has to do a task based on what that product is going to be. So if it's building bicycles or something like that, they need to use a specific bolt for a specific color frame or something like that. They got to know what it is that's going to be built. Process data is how well do we build it. So if you think about, just kind of the old-fashioned station 1 to station 50 concept that I've mentioned before, is every station something happens. Well, did it happen correctly? That's the key. So a lot of times what we'll do is, and Baloff is in vision as well, as far as machine vision, and then inspection cameras. They'll use an inspection camera between a critical station. So let's just say there's a critical process at station 10, and that process happens. There's an inspection camera right after it comes out of that station to say go or no go. Is everything seated correctly on there? Is an O-ring out of place or something like that? If there is, we can kick it off the production line right now, as opposed to waiting until it goes all the way through the process, and we got to add all that value and time and material to the product that may end up just going to scrap or eventually have to come back to rework. So the key is to get it off the line as soon as possible, get it into rework, and then put it back on the line. That saves time and money. Lineage data, and this is what I was talking about earlier, as far as where did all the parts come from, right? So again, you could have multiple suppliers for one part, and let's just say I have a product recall, I have products that are failing in the field. How can I identify, what I don't want to do is recall every part that was made for an entire year. So how can I limit that recall? I can identify the part that failed, one, with RFID, and after I identify that part that failed, I can identify every finished good that had that specific part on it by using RFID. Again, critical, and I use recalls for an example, but lots of different applications where you'd want to know exactly, to be able to trace the parts. Where did they come from? Who was the supplier? What was the date that the parts were manufactured, etc. So lots of different applications, and this just kind of goes into the details of like manufacturing of seats, for example, automotive seats. Lots of different combinations of possibilities is what this ends up being. And really, that's what flexible manufacturing is. The days of manufacturing one product on every single line, those days are over. It's usually multiple products on one line, and you have to retool those lines. So for flexible manufacturing, how do I help operators differentiate between a tan seat or a beige seat or a light tan seat? So RFID can help identify exactly the facts of what is actually to be built. And then process data. This is what I mentioned earlier: is when there's a problem, it's time to kick it off the line immediately. You don't want to add value to something all the way down the line, and then it's essentially destined for scrap or rework. Let's get it off the line immediately. And this is just statistical process control. And you can see these washers when they come down the line, the difference between this one, it has a brown bezel on the front of it. You can use a vision sensor to identify, hey, wait, this is not a white bezel on here, there's a problem. It gives you an indicator light to the operator to say, hey, we're kicking the part off the line, something's in rework, and then send that over to rework. They take care of it and put it right back on the production line, and it goes through the next station that it's supposed to go into, again, as opposed to waiting all the way to the end of the process and you have scrap or rework. Sorry about that. And then lineage data, I mentioned this earlier. Again, it's just tracing all the components back to their source. A big part of this is for liability claims, regulatory compliance, government regulatory compliance, and for recall information, as I went into the details of that earlier. Again, it's about secluding it down to a specific number, a specific lot number, a specific range of lot numbers. That way I'm not doing a complete broad level recall and recalling parts that may not even be affected. So RFID can help with that. And this is just an example of the lineage concept of every single one of these parts on this fuel injector have a barcode on them. And as this part is being made on a production line, this little tag here, this little right angle in the middle of the screen, that's an RFID tag. So every one of those fuel injectors that's being made, when it goes down to, there's 12 parts to it, as it goes down the line, the barcode is being read and being written to this RFID tag. So by the time it gets to the end of it, it knows every specific part that's on there. So you read the RFID tag and you can tell that orange clip is from my supplier in Tampa, Florida, that the red O-ring there on the bottom is from my supplier in Hermosillo, Mexico. Every single part, you can know the origin of that part based on the fact that as I was building it, I was reading the barcode automatically writing it to the RFID tag there. So when it's a finished product, you know the details, the true details, the lineage of that part. So when I talk about logistics, again, yeah, usually the primary system we're talking about is UHF because it's longer range. That's really what, just a rule of thumb, and this is not in stone by no means. A rule of thumb is the higher the frequency in RFID, usually the longer the read range. Now, it depends on the size of the antenna and things like that. But just by a rule of thumb, UHF is longer range, so it's the one that's actually being used the most for logistics applications to do automatic reads as something's being loaded onto a truck, as something being unloaded from a truck. Being able to get that longer read range helps that to be automated, because now I don't have to have a operator walk up and scan something really close. So automation in the RFID world means doing it with a fixed reader. That way I don't have to have an operator, pull a trigger or initiate that read some way or another. But that's still an option. And in some cases, having that mobility for an operator is very important. So it may be kind of a quasi-automated system. In a case where they're using a handheld, they can use that long-range handheld, pull the trigger, be able to read multiple tags, and then identify exactly down to that specific tag what they were looking for. So it's always a good way to look at it. And sometimes handheld readers provide a good segue from what I would consider a full manual process to a really automated process. And again, automation usually is a fixed RFID reader where I don't have, it's an automatic read that's generated. I don't have to wait for somebody to initiate it with, hitting a button on a PC or a PLC. That read takes place automatically. So there's two different ways to do it, and Baloff has both fixed and handheld readers. And this just kind of reiterates that concept, and being able to read things offline. That's where handheld readers come in as well. If you have a reader that's a fixed reader on the production line, and let's just say you have to pull it off, it goes into rework. And now how do I read that when it's offline? In the past, we'd have to pull a reader off the line. It's still tethered to a cable. So our customers requested we have mobile readers, and we responded with mobile readers that also has software on it. So again, handheld readers sometimes provide that segue or that evolution from a true manual application or a manual process to a quasi-automated process. So again, I mentioned what we do LF, HF, and UHF at Baloff. Lots of different ways to address an application. And yes, there are benefits from one over the other, and we can help with that. And the key is just identifying what are the attributes of a system, what makes the difference, right? What is the difference between using 125 kilohertz or 13.56, et cetera? There are benefits of each one over the other. So look, for low frequency, for example, has the best tolerance around metal. Well, just about every plant out there, there's a lot of metal around, right? So HF has tolerance, but LF has a little bit better tolerance, a little bit shorter read range. So there's things that you have to give and take between each frequency, but that's the key. One of the biggest advantages that we have in the industry is having all three frequencies, and then having all the different form factors, all the different tag sizes and shapes and different ways to be able to get that read. That's the key. And rarely do we have a hardware conversation. And I'm going to say never in the first conversation. We're talking about your application. That's the key. And then the second conversation, we may start to talk about like, well, since you want something more than a 3-foot read range, we're probably going to go with UHF. So the key there is, you think about the concept of a hammer, and I use this with even our sales guys a lot of times, is there's lots of different hammers out there that are made for different things, right? So there's roofing hammers, there's sledgehammers, and you wouldn't want to use one for the other. They're both hammers, that's for sure, but you don't want to put your roof on with a sledgehammer, and you don't want to hang a picture with a sledgehammer. But a standard hammer will get the job done when you're doing your roofing or you're hanging a picture inside your house. So again, it's a tool for every job. And then high frequency as well. Again, a very broad portfolio. I mentioned the BISV, that's this processor right here that'll do multiple frequencies into one processor. This is our longer range HF. We do both global frequencies, which is very important. This frequency can be used all around the globe. Okay, so one of the differences that between HF and UHF technology is that so UHF has to be used within the region. So UHF, the UHF frequency is managed by the FCC. So we have to operate at a certain frequency here, and then there's a different frequency in Europe. There's a different frequency in Asia, for example, for UHF. For HF, it's global frequency. So, you know, if you're a global company and you're shipping a machine out with RFID on it, more than likely, if you're using UHF, you're going to have to, you know, obviously you'd equip your, if you're building all the machines in the US, you equip your product, or you equip your machine with the frequency for where it's going. That's in UHF, for example. With HF, it doesn't matter where it's going, it's the same frequency across the globe. So again, UHF is the longer read range, but again, there's a standard that exists, much like the ISO standards for HF, but it's regional specific, and that's the key. So, and again, all of our frequencies, whether it be LF, HF, or UHF, we speak Ethernet IP, Profinet, Profibus, you know, all the major control platforms, CC Link, EtherCAT, etc. In addition to TCP IP, meaning I can connect to a PC or a server, as well as RS-232 serial, and in some cases USB as well. So I mentioned this earlier, you know, how do you decide, you know, what system is best for your application, or what do we use to decide that? And the benefit is knowing your environment, which means it's very important that you get your rep from JH Foster on site and get your Baloff rep on site as well, so they can identify in the environment exactly what we need to overcome to maximize or to optimize the reading of the RFID tag. And that's the key. Environment is the number one driver to select the system. Next is how much data and how fast, meaning, you know, you might have a super fast production line. Well, how much data is being written and read, and then how fast is the pallet or the whatever the tag is on, could be the raw part itself, how fast is that moving? That's the key. And this is a big advantage for Baloff in the RFID world as well. We specialize in reading a whole lot of data really quickly. And again, the required read-write distance, that'll tell you which frequency you're going to get down to. Again, if it's really pretty much anything over 2 feet, you're going to go with UHF. That's what the driver for that frequency would be. Tag and reader form factor, because of space limitations. You know, again, we're not trying to wedge a technology into a space, and sometimes physically, literally here, you don't want to put a tag into a place that it just doesn't fit. We probably have a tag for no matter how small that space is. We actually have a tag as small as 3.5 millimeters that can be put on a part and actually buried into the side of the metal, flush mount on metal, and still be able to get that read. So a lot of different ways to get a read on a tag. And then of course, communication protocol, which I've mentioned multiple times here. We have all the major control platforms in addition to the Ethernet, TCP IP, RS-232 serial, and USB. So these three systems are what I call the three pillars of RFID, because I'd say probably 60% of our applications are addressed by these three systems. Again, I don't want to go too much into the hardware here, because it really depends on your application as what would be used. But let's just start with IO Link, for example. This is just the standard data requirements. Means if I'm not going to write any more than like 96 bytes of data, and a byte in the RFID world is essentially one character, you know, a letter or a number or a special character on your keyboard. So I have 96 characters. Once I have more than that, I probably want to move up to the BISV system, and then the rest of our systems as well. So like the all-in-one system is also very good at being able to read a lot of data really fast. So IO Link, though, one of the advantages of IO Link is that I can mix the environment with other automation technology. So I have this IO-Link master here in the center, but I can put a measurement device on here. This is what we would call a BTL, a linear measurement device, used a lot of times measuring any kind of linear movement. I believe we go up to 7 meters in some cases, but being able to do this in this mixed environment on one processor, it really gives you the flexibility to put a lot of different, whether it be a sensor, valve connector into one system, and to have all that data transported over one network. That's the key. You don't have multiple networks to manage out there, so it simplifies the control platform, really simplifies the cabling, as you can imagine here. You can have all these devices into one block, and then you have one run going back to a switch, or even going all the way back to the control cabinet, but really eliminates that big rainbow spaghetti that you used to see in control cabinets. So again, IO-Link really is about having that mixed environment, or if you have RFID and you have sensors that you're getting ready to deploy, you can have those all in this one processor and all on the production lines. Again, so it's all speaking one language back to the PLC or PC. Again, the IO-Link advantage for Baloff is we've been doing it longer than anybody else. We were talking about IO-Link before it was even cool. And IO-Link is not a Baloff-specific technology. It's a global consortium. Everybody can do it. Probably in the last few years, everybody has started to do it. And yes, the products work interchangeably. So theoretically, you could use a Baloff reader in a competitor's master and vice versa. So there's a lot of flexibility within IO-Link, a ton of flexibility. But again, we have the broadest portfolio from a form factor standpoint as well on these RFID heads. And then the BISV, again, this is about the higher memory and the faster read rates, et cetera. So again, all of our major, I apologize for that sound, all of our major frequencies go into one processor. And again, the all-in-one reader. So the system setup and wiring is where this one really differentiates itself from everything that's in the market. So it's a point-to-point reader. So there's 3 connectors on the bottom of this reader. One is a network in, one is a network out, and one's power. So you go directly to it. So you think in a case of what we would call like islands of automation, for example, you may want to start with just one reader. Well, then how do you expand from one reader to multiple readers? There you go. It's just very simple daisy chaining technology all the way down the production line. So you drop power out of each one of them, you put an Ethernet cable from one to the other. So this is available currently in Ethernet IP and Profinet. But again, one connection back to the PLC allows you to have multiple heads out on the production line. So why Baloff RFID? We've been doing this for a long time, and we've been doing it in the industrial space. That's the key. There's a lot of players in the RFID world out there, and there's a lot of players trying to get into the manufacturing space. This is our core competency, is in the industrial manufacturing space. We are an end-to-end solution provider. We do hardware and software integration, data handling, cloud services. We can connect to the cloud. We can handle the data from the device to the cloud. We're the market leader in IO-Link RFID. Again, the largest portfolio of hardware in that world. The most number of, or the largest variety of form factors, which is critical, and especially for machine builders who are building small machines. We have a lot of those readers that fit into tight places that nobody else has. The best support chain in the market, and the guys at J.H. Foster here really represent that for us as well, as that's your first line of support from beginning to end, from pre-sales to post-sales. So those guys have access to the highest level of support within Baloff. So in addition to the guys at JH Foster, you have your local rep, which is Christian. That's a Baloff guy. He can come in. I am available as a traceability specialist. You also have what's called a TAS person out of Chicago. That's Randy Dang, and he can come in for higher tech applications where he's required for that, although Christian can handle a lot of the technical aspects of an RFID application. And then they have access to people like me that are in the field, and then our team back here in the Florence, Kentucky office that can do testing in our lab and send tags back and forth as needed if tests need to be run in our laboratory. So again, the best support chain in the market. It's set up for industrial manufacturing. We know downtime is unacceptable, and that's how we operate. Willing to customize or modify parts to address applications, and this is critical. There may be a situation where you say, well, I have a very small part, or I have a very unique part that has to have this, these qualities. We can help with that. Give us all those details, and a lot of people always ask, like, well, what's the minimum quantity to do a customized part? There's really not a minimum quantity. Again, it just depends on exactly what's needed, and then sometimes it's, whether or not it can be used for other applications. There's lots of different ways. Oh my, so sorry. Hang on for 1 minute.
While we're waiting for Wolfgang, this is Christian Gullickson. I'm the area sales manager for Baloff in your area. And one thing that I wanted to point out while we're waiting for Wolfgang is that right now, about 90% of what I'm working on is RFID projects for customers like yourself. And what we're finding is there's several customers out there that are looking to make sure that all the raw components going in to build a component, or whatever it is you make, a lot of people nowadays are starting to use RFID to check the raw components going into that, so that you're not producing a day's worth of product and finding out that the wrong raw component was used. Or even one of the bigger applications I'm working on with customers like yourself is ensuring that if you have change parts in your equipment, that the correct change parts are being put in and not causing damage to your actual machines. One of the things that I'm finding most customers are trying to do is that with finding the right people to work right now, it's not easy to find the right people to run your equipment. And so putting things on there like RFID is ensuring that the correct components are put on your machine ahead of time, not causing a crash and causing $100,000 worth of damage to your machine, or just the downtime you're experiencing while you're waiting for those parts to be remanufactured.
I'm back.
Wolfgang, you back?
Yeah, thanks for that, and I sincerely apologize for the sound there. So finally, Baloff can address more applications, and I really harped on this specific bullet here, and this is critical. We can address more applications with our current portfolio than any of our competitors, and it's because we have a gigantic portfolio to begin with, and we are willing to customize or modify products to address a specific application. Your application is the center of how we operate, and we've been successful at doing that for over 30 years here, as I mentioned. So, but that's critical, and that's very important. So a lot of times, sometimes some customers will get frustrated by the number of questions that we ask ahead of time. That gives us a competitive advantage in many cases. Is that we like to know everything there is to know going into that application ahead of time, everything from the environment to where the data is going to go and how the data is going to be handled. So we're extremely thorough from the beginning to the end when it comes to an RFID application. And that's proved successful for us over, 40 plus years actually, with doing a lot of these different applications. So that's all I have. Any questions, please throw them in the chat. And that's my state record fish that you see there on the screen now. I live in Kentucky, so I live very close to the Florence office. And that's, I know you guys are walleye fishermen up there. That's actually a saugeye, which is a hybrid between a sauger and a walleye, 9 pounds even, which is the Kentucky state record. But any questions about RFID or fish?
Are you able to see the questions in the question box?
I cannot. Let me see if I can do a drop down here.
Sorry about that. I missed that one. I was watching the questions and the chat the whole time and didn't see that.
Okay, I do see something here now. Wolfgang mentioned something about IDing when someone enters the plant. What does that look like? Is there a reader on a door frame? Is there to do the reading? So yeah, I mentioned being able to do, so I was talking about access control and saying what we do really isn't limiting access to a building or something like that. But yeah, there's essentially a reader outside the door. There's a reader on the door frame, and we actually use this to get into our building here at Baloff. Reader on the door frame, you show them a key fob, and there's a mechanical device in there that unlocks the door, unlocks the bolt. Is there a way to do that without requiring their employee to present their ID every time? In some cases, yes, but really it's pretty easy to fool it if you want to put metal, so in a case where you just want to ID somebody automatically as they're coming through, it depends on the application. And I don't mean to be wishy-washy there, but if a person wants to hide an RFID tag, you got to remember humans are mostly water, and RFID or radio waves do not penetrate water or metal. You can read on metal and even down in metal a little bit. But if you want to hide that tag, so if you're trying to limit access control, that's not the way that you want to do it. Let me see here. Employees movement around the plant. So yeah, so let's just say if you're doing access control or a machine access control, it does not track the operator around the plant. So and everybody has that fear, right, of being tracked from where they are and whatever. It doesn't do that. So the only way to track somebody is to have a reader at every single location. So if you want to track somebody when they walk from their machine to the dining hall or to the cafeteria, then you have to have a reader at each of those stations to say, okay, this person just arrived at this area. So that's all I see in there is just that one series of questions. Can you guys see any more in there?
No.
That is the only one I see as well.
Okay. But please feel free to follow up with your rep, to get Christian back involved, to get me back involved. I'm glad to get on a call with you one-on-one. I can be on site. We can do it via Teams meeting, via GoTo meeting. However we need to do that, we're very flexible. Again, and we'll ask you a lot of questions, so be prepared.
I'd just like to add one more thing in regards to the question, and that is that we typically don't track somebody around the plant. We typically track them into a specific room or logging on to a specific machine, but very seldom tracking someone to their actual placement within the plant.
That's right. Yeah. Thanks for following up with that, Christian. That's critical.
There is another question about, have you applied any of this technology in a hospital setting?
Yes, RFID in a hospital setting is very common, actually. Common in wristbands, common in tracking assets, whether it be beds or high value, what we call the cows or computer on wheels. Lots of different ways to use RFID in there. But yeah, so it just depends on the actual application itself. We're not into patient tracking. That's not what Baloff does. But there's still assets within that plant, within the walls of a hospital, that need to be found when they're required, and RFID is being used for that as well. Absolutely.
And also, they keep track of when the system was a machine like that, one of the assets they have, it'll keep track of when that asset was last calibrated, say.
Absolutely.
So I actually pulled out the question box, and there's several questions. So I know we reached 9 o'clock, so I don't know how you feel about answering all of these, or we can.
Yeah.
I can at least send you the person, and you can email them direct. But
I think that's the best. Let's just do it
okay.
that way. I have to jump off.
Yep.
If you can send me who sent the question and the question, I will absolutely answer those, and I'll answer them today. So, and I'll copy you guys there as well.
Okay. Thank you so much.
Thank you,
Yeah.
Wolfgang.
Thanks, everyone. Thanks, guys.